There, okay, now I'm recording. Okay. I think this is where we are. But, so my advice in general is, come to office hours, no one comes. And I know it's weird. Who here's like, yeah, I don't like office hours because I don't like online. Yeah, I know, it sucks. I hate it too. I really do. But you gotta come. Get the help. There's so much. I don't even know if St. FX has ever had a class that has had as much office hours as this class has this semester. Take advantage of it. I was joking with a student the other day. I think I've had less unique students come to office hours than I have assigned office hours a week. So like make use of it. The TAs are paid to be there. So come to office hours. What else? The trick for assignment 3 is this. This will likely get you. Make sure you understand it. We're going to talk slightly more about it today, but also follow the instructions. And obviously, I know obviously, but really, it's going to be focusing on, okay, do this step. Only think about doing that step as it's described. A lot of people will read the whole thing, because this assignment you have to start from scratch. So a lot of people will read the whole thing, which is a good thing. Do that. Start by reading the whole thing. Understand what you got to do. But then once you start focusing on doing step 1, you're kind of thinking about everything else that you think you have to do eventually, but you're thinking about it all at once. The trick is one thing at a time. Nice and slow. This is what this function says. I got to do that. I'll code it up. Now this function, this is what I got to do. I'll code it up, and so on. Go with that strategy. In the end, I'm going to walk you through in the description on how to put the pieces together. But try not to think about the whole assignment as one giant ball of stuff you have to get done right now. It's step 1, step 2, and you chisel it away. Piece by piece until next thing you know, you're done. Anyway. Okay. All right, well, of course, we know this already. If I say, okay, A equals ABC, what's the length of this list? Yell it out. 3. It's very uninspiring. Come on, tomorrow's Saturday. There's 3 though, right? What are the types of things in here? Strings. Yeah, I mean, they're single letters, but they're all strings. What do I type to get A printed out? Well, here, let's just do this one real quick here. A equals A, B, C. Well, I have to say, okay, the thing that gets me to the list, A is a pointer to a list, and then I index it with, well, which one do I want? Well, I want the 0 one. Give it a second. There we go. A. Perfect. We know this. We know this. We've been doing this. Great. So what's the next question? Okay, that's it. Now it's getting slightly tricky. We're already familiar with this. We've already been doing it. Assignment 2 did a bunch of this. But now let's really talk about it. I say, okay, A is the list, A, B, C, okay, great. And then I say B equals that. What is this going to do? Well, B is going to be a list. But let me ask you, what's the length of B? 1. What is the type of thing in B? It's a list. I suppose more accurately it's like a pointer to a list. But yeah, it's a list. Okay. So let's go back here and B equals A. Print B. Let's just see what happens. Okay, there we go, there. That's it. If that second line is throwing you off, you're thinking too hard. You're trying to connect dots that aren't there. All it is what does the code say? There's no magic here. It says, okay, create a list. Why do we know? Well, we create lists by like opening the square brackets and closing those square brackets. And what's the thing we're putting inside of it? Well, the variable a. But what is the variable a? Well, it's a pointer to that list. Great. So it's a list with one thing in it. And then I print out b. Well, we see that b is a list with a list inside of it. I mean, I could do this too, I suppose, which is going to be a little weird. There. Now b has length 2 because it has 2 pointers to, the same list, but interesting nonetheless, right? By the way, pay special attention to this. This might come up during the assignment. If I do like this. Okay, now I've got 3 of them. I wonder what's going to happen if I say like a at 0 equals, wow, and then print b. I'm not going to hit run yet. Take a second. Ask, the question I want you to ask yourself is, what's going to be printed out? What do I expect to see? Slow down. Don't connect dots that don't exist. What does the code say? Remember, what does it mean? That's a pointer to a list. There's one list and everything. Think about it. Let's see what happens. Raise your hand if you were right. Raise your hand if you were wrong. You're not crazy if you were wrong because you're thinking, well, wait, but remember, here's the rules. And we can draw this out. And in lab yesterday, and it's going to be the same thing for lab today, it's starting to get to the point where, let's see if I can find a marker that works. Perfect. It's starting to get to the point where the level of complexity we're dealing with here, with our code, our algorithms, we're starting to get more and more complex. And this complexity, you're not going to be able to keep track of it in your head. You're not. If you can, that's amazing, but don't expect to. Grab your sheet of paper, grab your pencil, and just draw it out. What's happening? What are the values of the variables and whatnot? So here's what I'm going to do. Here, we've got the list. A, B, C. And at the very top, we're saying, well, we're creating a variable A that is like a pointer to that list. Great. Then I come along and say, B is going to be a pointer to a list. But what do I put inside of it? Well, I put A. Well, A is like this pointer. All of those things are pointers to the exact same one single inside list. And if at any point through any of those pointers I go and change the contents of this list, it changes it's going to change it for all the pointers because all the pointers are pointing to the exact same one single list. This is going to come up in assignment 3. If you make that mistake, if you're like, oh no, I changed it once and it changed it everywhere, this is what you need to think about. Oh, right. They're pointers, not actual lists and whatnot. Remember, it'll get you. And it's okay if you're going through and you make this mistake and you get stuck. This right here is one of the trickier things that people learn in first year, first semester computer science. This is a tricky idea. It's weird. It seems to act differently, although we saw that it doesn't really act differently from the system side of things, but it gets you. Expect it to get you. These are the types of bugs that hit every programmer no matter what experience level. They're going to mix these things up every once in a while. Be like, oh, right, it's a pointer. It's going to happen. For better or worse, get used to it. Anyways, let's actually resume what the question is saying. All right, how do I get A printed out? Well, let's assume we have to do B. Let's go here. So if I print out B, I suppose I should make it to what I was actually asking. There. If I print out B, I get the whole list of lists. Again, let me ask you, what is the length of B? Yell it out on the count. I'm going to count down from 3. 3, 2, 1. 1. B has one thing in it, and it's a pointer to a list. That's it. If I say B at 0, will I get that pointer to the list? B at 0 is that whole inside list. And then, how do you index lists? There's no trick here. There's no magic. If I know B at 0, at index 0 is a list, how do you index lists? Oh, with square brackets. So if all of this is a list, well, I just say like 0. Great. Done. You've been doing these things in like assignment 2. You've already done this. But now we're like really, really talking about it. Happens if I do this? Well, we kind of saw it, but let's just do that and see what happens. Let me ask you, how many lists, not pointers to lists, how many lists exist inside this program right now? Anyone have an idea? What do you say? 3. 3. Why?
Because there's A, there's B, which is A plus whatever's added, and then there's that list that's added to the end of it to make B.
Absolutely correct. There's 3. We've got A's pointing to a list, B's pointing to a list, and then inside B, the thing at index 1 of B is pointing to another list. You're absolutely right. 3. How many pointers to lists do I have up there? Take a second and think about it. Raise your hand if you think you know. I'm not asking. Yeah, I want to know how many pointers. Was your hand up? No? Okay. Somebody else. What do you say?
2.
2. No, that's not quite right. Good try, though. Well, why do you say 2? I'm curious.
Because A and B would be the only pointers on the screen on there.
Okay, so A and B are 2 of the pointers that are there. You're absolutely right. Maybe I should reword this. How many... I see how this could be confusing. Let me reword it then to maybe make it slightly more clear. How many... Because I know why you're saying 2. You're saying 2 because it's like, well, there's 2 pointers, right? But really what I'm asking is, how many different pointers are there regardless of what they're pointing at? You might have more than one pointer pointing to the same one thing, and that's okay. So I'll ask the question again. How many of those pointers do we have currently up there? 4. Why do you say 4?
A is that list, B is the other list, A is in pointing to the list that's in the list, and then B is print B.
So what we're doing here is we've got this pointer. Do note that this doesn't correspond exactly to what we have up there anymore because this is one list. Let me fix that. Anyone see the eraser? Okay, well, let's ignore this. Let's not let it distract us. We have A is a pointer. B is a pointer. The index of B, index 0 of B is also a pointer. It's pointing to the same thing that A is pointing to, but those are 2 different pointers. And also, that whole list there, that's inside the list of B, that whole list, really it's not a list inside a list. Really, it's a pointer to a list inside of a list that is pointed to by a list pointer. So there are 4. Which is weird, right? But it checks out. It follows all the rules. how do you get A printed out? Well, I mean, I can still say A at 0. And similarly, I can do like that. Great. And do note that this A is that A, not the variable A being printed out. All right, well, we actually already did this one. Skip it. Ooh, here's a fun one. Bunch of weird stuff going on there, right? How many lists do I have now? Before there was 3. How many more did I add? Somebody else. Someone's got to know. Nothing really had changed too much. What do you say? 5 or 6. Well, let's see. We've got the thing A's pointing to, that's 1. The thing B's pointing to. The thing B at index 1 is pointing to. The thing C points to. And then the thing that C at index 1 points to. I guess it's 5. Who here sees 5? Did I miscount? If you saw 5, why didn't you yell out 5? Come on. How many pointers to lists? You know what, let's not do that one. It's starting to get hairy. But there's a lot of pointers to lists here. Remember, pointers to lists and lists, very different things. It'll become more and more easy to remember these things with practice. Here's the funny thing about computer science too, is there's very little memory work. There's some basic things, you have to memorize how a loop works, I suppose. But once it comes to solving problems and whatnot, it's really just creative problem solving with the tools that you know how to use. This is one of those things that you kind of just have to remember though. It'll become so obvious with experience. But this is one of those things of oh yeah, I know that those are pointers, not lists, blah, blah. You got to remember that. And you'll probably forget it, like I was just saying. I forget every once in a while what I'm dealing with. But anyways. All right. Now we're going to move on to something that seems very, 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 very similar to the Python lists. These are arrays. Now, big warning. Raise your hand if you've programmed before in another language other than Python. Really high, I want to see. Okay, a couple of people. Those of you are probably familiar with arrays. What I'm about to talk about are not those arrays. It's a sad, unfortunate coincidence. I don't even say coincidence. It's a sad, unfortunate situation that it's got the same name. And they act very similar, but they're not. Point being, forget everything you know about arrays for now. Okay? All right, Numpy Arrays. Let's have a quick look. If I say something like this, okay, great. Syntax is a little weird. I have to have NumPy imported, and then I'm making A this array. Here, I'm gonna do this. Let's copy. Stupid arrows. Here's a little trivia. Anyone have any idea why there's arrows there? What they mean? What do you say? Yeah, the interpreter would kind of act with arrows, you're right. But of course, we're not really using an interpreter, so everything's okay. So what do we see? Well, 1, import NumPy. Okay, all we have to do is that 1. It's fine. We print out A. Yeah, okay, but what is A? Well, you'll see that the thing inside the parentheses looks an awful lot like a list. It's because it is a list. Well, it's a pointer to a list, but it's like the list. The numbers 5, 4, and 2. And then when I print it out, we see 5, 4, and 2. Great. But I had to wrap it in that numpy.array. And this is how we tell Python, okay, make an array with these values in it. And it looks a lot like a list. It's going to act a lot like a list. I can ask the length of it. I can ask the type of it. It's a Numpy array. Okay, great. So it looks a lot like a list. Remember how like lists were mutable but strings weren't? Well, what if I do a at 0 equals 66? Okay, so far so good. What happens if I do this? Like a at 0 is a word. And now it gets really mad at me. If this was a list, it would have been fine with it. Lists in Python let you put whatever types you want in there, mix and match, have fun. Numpy arrays, no. With Numpy arrays, if you want your array to have integers in it, it can only have integers in it. If you want your array to have strings in it, you can only have strings in it. We can make a Numpy array of strings, but we can't mix and match. So there is, I guess, some limitation there. So yeah, that's not okay with a Numpy array. Now let's do an activity, because I've been talking for a while. Do this. Create 2 arrays of integers, each having the same number of elements. It's critical. And see what operators you can use. Remember, you could do like multiplication on lists, addition on lists, which kind of was a concatenation. See how those work with arrays. Play with them for a couple minutes and see what you can find out. Best way to learn it is to poke and prod and see what you can do. I'll give you a couple minutes. I will say it's exceptionally dedicated and very inspiring to me when I see people even doing it on their phones so they can actually do it. How hard is it not to fat thumb everything? Yeah, you're doing fine. Yeah, you're okay. So of course, when we add two lists together, they concatenate. So I figure, you know what? Arrays will probably do the same thing, right? Huh. They didn't, did they? What did they do?
Took every single index of the array and add them together.
Yeah, it did kind of like vector addition. Kind of like algebra, right? You know, it just adds the things place by place. What do you think would happen if you tried to add things of a different size together? Well, it's going to say, yeah, you can't, no, that's not okay. Which makes sense, right? How would you do that? I wonder what happens if I just add a number to A. Huh. What happened there?
It added 5 to every number.
Yeah, it just added 5 to every number. Interesting. So this just kind of was like a linear transformation. It just moved everything up. Huh. You know what, with that in mind, look at that. That seemed to scale everything. Neat, right? Who here has taken algebra? Who here looks at this and going like, yeah, this is just algebra? Yeah. Very simple. This is handy. This is where Numpy and Numpy Arrays start to be really awesome if you're doing anything really mathematical. I wonder what happens if I do like A times B. I guess it does like positional multiplication. Kind of cool, right? So that's cool. Did anyone try any of the other operators? I mean, no big surprise. What about division? Whoop. What's going on here? Oh, there we go. Okay, cool. Yeah.
You also know that like a single list, like A, you divide by 1, it turns everything from integer to float.
Yeah. Cool. Yeah, I mean that kind of happened here, right?
Yeah.
And I guess if you do that, it's a quick and dirty way to just make everything a float. That's kind of cool. Huh. How about that? I wonder if we do that though. Yeah. Okay. So that's pretty neat. So another thing that's cool about NumPy is it comes with a whole bunch of functions that you might like to use. And it also comes with what we call attributes. Remember with strings how like if I had a variable that was a string, I could say dot, and then we saw those like functions that we called methods. Remember there was like capitalize, right? Which would take the string and then just capitalize every letter. Those are called methods. And there are a lot of methods for NumPy arrays as well. But there's also like these things we call attributes. D-type. Notice there's no like parentheses after that thing, A.D type. There's no parentheses, but if we wanted to call a function, is shape an attribute, or I guess shape isn't also an attribute. Max. Max it's a function, and it's telling me it's a function. If I want to call that function, I got to do that. But when I did shape just tells me the shape of it. In this case, it's a 3 by nothing array. It's one-dimensional. And the dimension has 3 things in it. That's all it's saying. So attributes and functions, or pardon me, methods, are things that belong to objects. And Numpy arrays are objects. So like strings, we had all those methods, but attributes are a little different. They're not methods. They're kind of like just variables that belong to the instance of the object. Let me show you what I mean. This is probably best explained as an example. Let's do this properly. Print. So what I mean is shape. That's an attribute. And that's just like a fact. It's a piece of information about that object. Every Numpy array has a value for its shape, but they can be different. So although shape is like the variable holding on to what like the shape of that array is, even though they have the same name, they belong to different instances of the same object. In this case, the objects are Numpy arrays, but we'll see that obviously they have different shapes. A's shape is 3, C's is 6, because there's 6 things in it. So each instance of these objects, they all have the same attributes, but their values will be different. A really easy example of this is I could code up and make student objects, okay? And then we could create student types inside the computer. And maybe I want all my students to have like a first name, a last name, their student number, their email address, all these different things. Every student I could make will have those attributes. But each instance, in this case, A and B and C are instances, or they're pointers to Numpy arrays. They're all Numpy arrays, but they're specific instances of those things. So imagine I coded it up such that we have student objects, right? So then I create a new student object, one instance of these objects for each student in this room right now. Every one of you has a first name. But what's your first name?
Oscar.
What's yours? What's yours? What's yours? You all have the attribute first name, but the value associated with that attribute is dependent on the instance. This is very critical, and it's going to come up a lot more in a couple of weeks. But anyways. Okay, yeah, blah, 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 D type, okay, blah, blah, blah. Cool, sum, max, mean. I mean, these are things that we didn't get for free. We didn't get these for free with lists. But suddenly I can use these functions, these methods associated with those instances of objects. Pretty cool, right? And of course, when I ask the specific instance, hey, what's your mean? It's going to tell me the mean associated with that instance. The fact that this is a function and not an attribute, I guess means that it must actually have some code that's executed and it goes through and it does the calculation. Where the attributes, it was just already known. It was just a piece of information that was already there. Great. Okay, great. Yeah. Here's a cool thing. Let's play with this. I'm going to make it D, I guess. These Numpy arrays are going to act kind of like how strings were acting. Remember how I couldn't go and like change the string? but I could like make a copy of it and then change stuff while making the copy. That's what's happening here. As type will it'll change the type of whatever A is, but a copy of it, and then assign it to the variable D here. So A is left unchanged, but D now is a pointer to another Numpy array. Okay, making arrays bigger. In Python, with lists, it was easy. We could just append, or we could concatenate lists. But with Numpy arrays, we can't do that. We can't change the arrays. We can make copies and change them like with strings, but we can't change it once it's like there. So, here's how I would have to do it. And this is important to note the nuanced difference. I'm going to call it E, so we're not overwriting our other lists. So I'm saying, okay, append 5 to A. But really what's happening is, it's making a new array with A in it, and then also the 5. And it creates a new array, assigns it to E, and then prints out E. Great. But A is left unchanged. We can't go in and make it bigger. Once it exists, it exists. That's it. Any questions about this? Because it's weird. Now, note that this actually isn't a method. I know you're like, but hold on, you say like numpy dot. Well, hold on. Numpy is like it's kind of like saying math dot sign. That's not a method, that's a function from the numpy, from the math library. So this is like a function that takes an array and then something else we want to append to it. Don't worry too much about that. I was just letting you know. That doesn't matter too much right now at this stage. Yeah, it doesn't change it. So this should end up being trivial, so I'll just blast through it. What happens if I try to append walrus to it? Well, let's see what happens. Let's see. Oh, well, it worked. And who here is now thinking, well, a moment ago you tried to change something to walrus and it didn't work? Who here is thinking that? Because I totally did that. But what's the difference? Well, I'll just say it, but I think you probably know. It means take A, append a string to it, but I guess because we've made a copy of A still is only A. I never changed A. But because I was trying to append a string, Python was like, well, I guess they just want this to be an array of strings. So it turned it all into strings. Huh. So, arrays are less flexible than lists. Lists were very forgiving. We could do a whole bunch of things. Arrays, we can only have one type in them. Okay. But they also had different functionality, like when we added two arrays versus added two lists, we got different things. So although there's these differences and it seems like, arrays, they seem to be less general. I'm just going to use the lists. Okay, fine. But the Numpy arrays have extra power behind them. They're great for math. They're quick. Their implementation in the back end is fantastic. So although they're less flexible, they end up being really good at what they're good at. But they can't do what they can't do. Where lists, they're good at everything, but they're not as good as Numpy arrays at what Numpy arrays are good at. Yeah. Just like lists, you can have higher dimensions. I'll blow past that. Sometimes you might want an array, a Numpy array starting of an arbitrary size. Let's go down here. If I say z equals Oh no, I guess, I want to make an array of size like 5 and then print Z. Great. It creates something. It creates a NumPy array of size 5 that's just all zeros. I can make a multi-dimensional array. But if you do that, we have to do this funny thing here. Oops, I guess I have an extra parenthesis. I have to turn it into what we call a tuple. More on tuples in a moment, but a tuple is basically kind of like a little mini list. So there, we got this two-dimensional one. It looks kind of like a two-dimensional list. You know, lists inside of lists. But also note that, you know, if I index 0 at 0, yeah, but I can actually also like index kind of like with a comma as well, which is weird but cool nonetheless. So NumPy arrays let us do this. This will get cleaner and clearer with practice, so don't worry too much, but practice, practice, practice. You might not want zeros. What if you want ones? Well, okay. Oops. There, great. And then you might say, well, is there something for twos? I guess not. But we could really easily get twos if we do something like this, like times 2. Great. Times 200. Okay, great. There. Now again, raise your hand if you took first year algebra. Oh, what did I do wrong? I guess it has to be. What am I doing wrong? Maybe it only takes one. There we go. What do we call that? Here's a little algebra trivia. I'll give people a second to look at it and come up with what do we call that thing. I'll give you a hint. Think of this as like a matrix. Does that just confirm what you were thinking? Yeah. Just a quick poll. Raise your hand if you're like, yeah, okay, I think I know. Yeah. What is that? What that is? Really high, I want to see. Yeah. So what is it?
Matrix of value 1.
Yes, but we often have a special name for this matrix. Who remembers the special name of these types of matrices?
The identity?
The identity. It's the identity. And as a fun little thing, the name to get it is I, like identity, but instead of I, it's I. Huh? Isn't that funny? Look at that. Programmers have fun all the time. If you have no idea what I'm talking about, don't worry. That's algebra. We can slice arrays, great. We can reshape arrays. Here's a quick way to get something like that. Create something A-range. A-range is like range, but for arrays. Remember how range will kind of give you like a list of things from 0 to whatever value you do? Well, A-range will give you an array of things starting at 0 or wherever you specify up to the value you specify, counting by whatever you specify. And interestingly, we can reshape arrays by saying dot reshape to 5 by 5. Of course, it'll only work if it can reshape it to that size. But these are all really cool things you can do with arrays. Fantastic. Just like the for loops with lists, arrays are going to work just the same. For each thing in this collection of things, the array is just another collection of things. I know I'm blitzing through, but most of this stuff, it's just transferable from lists with tweaks here and there. If and when they come up for you, you'll figure it out. Whatever, great. So, I would encourage you to do this activity. It's probably a really good exercise. We don't really have time to do it right now. But yeah, I do recommend playing around with that activity when you get a chance. Any questions before we wrap up for the day? You just want to leave. Okay. See you later. Have a good weekend. And for those of